When you first learned algebra, every equation had one job, and that was to find a number. For instance, x plus 3 equals 7. Find out what x equals. Obviously, everyone should know x equals 4. But differential equations play a completely different role. Here, the answer we're looking for isn't a number, but rather a function itself. The equation doesn't tell you the answer, but rather it tells you how things change inside a system. This is the first video in a full series where we're going to learn all of differential equations, from the very beginning all the way up to the last lecture. So, starting off, what is a differential equation? So here's the idea. A differential equation is one that connects a function to its own rate of change, its derivative. To imagine this, I want you to picture a population of rabbits. As the population grows, so will its rate of change, because the more population there is of rabbits, the more there is to create offspring and create more for the next generation. So in order to map out this rate of change, I want to make an equation for it. dp, the differential for the population, divided by dt, the differential for time, equals some constant k times p. Notice how I never said how many rabbits there are. A differential equation doesn't need the population itself. Rather, it creates a rule for how they change. And if we solve this differential equation, it means we are finding the function that obeys this rule. And here is an exponential growth function. And that's the entire idea. Almost everything in this universe is defined by how it changes. For instance, take a falling object or a cooling coffee, a vibrating spring, a spreading disease, or even a planet's orbit. All of them have rates of change, and therefore all of them have differential equations. And if we can solve these differential equations, we can solve for anything that is moving or changing in this universe. In this series, you will learn how to solve and create differential equations and learn the language that the universe is written in. So here's what we're covering with this series. We're going to start with first-order differential equations, which are the simplest kind. We're mainly going to focus on techniques to solve them, such as separating variables and integrating factors, but we're also going to look at how to understand them conceptually, such as what they mean and how to understand them, as well as how to create them yourself. Then we move on to second-order differential equations. This involves springs, vibrations, and resonance, the same reason how suspensions work on your car. Then we move on to Laplace transformations. This tool turns calculus equations into algebraic equations. Then we learn series solutions for the equations with no clean formula. Finally, we move on to systems of equations and phase planes. We watch the entire system evolve. We will create beautiful spiraling pictures, and by the end, you'll be able to look at almost any changing system and write down the equation that governs it. What do you need to know before we start? Well, as this is often referred to as Calculus 4, you definitely want a big refresher on calculus. You especially need to be comfortable with derivatives, how to take them, what they mean, and integral solving. Almost every differential equation comes down to integrating. So Calculus 1 and Calculus 2 are going to be your foundation. They're your best friend. If you're rusty on integration, we'll brush up in this series. You also need to constantly lean on solid algebra, such as rearranging and factoring. Also be aware of your exponentials, logs, and trigonometric identities, since answers also often show up as e to the power of x, sine, cosine, and things like that. That is pretty much it. We'll cover a little bit of linear algebra, like matrices and eigenvalues, but that's for later systems, and we'll introduce them when we get there. You don't necessarily need a strong understanding of multivariable calculus, but it is recommended before taking this course. The bottom line is, if you can take a derivative and compute any integral, then you're ready. Everything else we can build together. So differential equations aren't just about numbers, they're about change. And once you start seeing the world in a certain type of way, it will never look the same. So while using calculus, we can begin. In our next and very first video of the series, we'll solve our first differential equation, which will be our first order differential equation. I'll see you there.